For exponential decay, let's start with the stuff we already know bots. If you don't know how to convert these different descriptions into exponential multipliers, you should stop this Google form, go back to the last one, and ask for help. It's really important that you understand how to get the multiplier before you get too far into this. If it helps, pause the video, try these first 3 examples yourself, and then resume the video to see if you've gotten the answers correct. For the first one, if something is increasing by 14.2% and we're looking for the multiplier, remember that means we're going to take 100% of whatever it is that this is talking about, and we're going to add to that the 14.2% increase. And that's going to give us a total of 114.2%. And the multipliers should always be converted to a decimal. So as a decimal, we're looking at 1.142. For most of these things, I would say don't round unless it's asking for an approximation or it tells you to round. So I'm going to leave it at 1.142. For the middle example, we have something that goes up by 6%. So whatever that something is, we're going to be paying or starting with 100% of it. It's going up by 6%. We're adding 6% to that. That gives us 106%. And then we're converting that to a decimal. 1.06 is the multiplier there. The last one, if something is quadrupling, we don't necessarily need to think of this as an addition problem. Instead, if something's quadrupling, it's kind of like we're multiplying by 4 each time. So this one actually starts to look a little bit different. We would take 100%, so the whole amount of whatever it is that we're looking at. And if it's quadrupling, we're going to multiply by 4. That's going to give us 400%. And we still want to be able to write that as a decimal. So 400% as a decimal. I'm going to get just a 4. For the 2 examples, we're looking at an example on the left for exponential growth and then an example on the right that's going to do decay instead. So the example on the left should look more familiar. It's what we were doing in the previous lesson. This one says the average score on the math portion of the SAT in Georgia has improved by 3% each year for the past several years. In 2012, the average math SAT score in Georgia was 476. We want to start by finding the multiplier. Remember, that would be 100% plus the 3%, giving us 103%, and as a decimal, 1.03. If we were writing an equation for this, it would be y equals. The A in this case would be the 476. The B multiplier is 1.03, and we're going to put an x for our exponent. Predict the average math SAT score in Georgia in 2020. So we're going to take that formula, 476 multiplied by 1.03, and this is going to be to the 2020 minus, and the year that this information was from was 2012. Okay, so we're going to use order of operations to start solving this, starting with the 2020 minus 2012, giving us an exponent of 8. 1.03 to the 8th power will end up giving us about 1.267. I'm actually going to wait to round this after I finish the final calculation. So without clearing out the screen, I'm going to go ahead and now multiply that by 476. And my answer for this one is going to end up being about 602.98. I'm just going to cut it off there. All right, on the right side, we're looking at an exponential decay problem. The average score on the math portion of the SAT in the country has decreased by 1% each year for the past several years. In 2012, the average math SAT score in the country was 494. The multiplier for this one's going to start off the same way. It's 100%, but because we're talking about a decrease, it's a subtraction problem. So we're going to subtract 1%. That leaves us with 99%. The multiplier for exponential decay is also written in decimal form, so that is going to be 0.99. The equation is going to have a similar setup. It's still going to have an a value, and that a value still represents the initial amount that it starts us with, the 494. The multiplier is 0.99, and we have our exponent. All right, last part here. Predict the average math SAT score in the country for the year 2020. So just like before, I'm going to set this one up, 494 multiplied by 0.99, and this ends up being to the 8th power again, because we're starting with 2020, and this data is from 2012. 0.99 to the 8th power is going to put us at 0.9227, and some other pieces. Again, this is rounded, and I'm going to wait with the calculator to go ahead and finish this out. So now I'm multiplying by 494, and my final answer here is about 455. And I'm just going to extend this a few decimal places by 84.